So here's number one, part B from the 2012 AB and BC exam. And in part B here it says use data in the table to evaluate this definite integral. Using correct units, interpret what this means within the context of the problem. So typically whenever you have a free response question like this, or a problem in a calculus textbook where you're dealing with the table of values, they're going to ask you to estimate the value of an integral with a Riemann sum. So this seems a little bit weird because we're not asked to estimate the value of the integral, we're asked to evaluate it. If you think about evaluating this integral, it's actually not that difficult to apply the fundamental theorem of calculus to this. If we want to do the antiderivative of w prime, we're going to be working backwards to w of t. So I'm applying the fundamental theorem of calculus. I found the antiderivative of this function here, and now I'm going to evaluate that antiderivative at the limits of integration and take a difference. So if I evaluate it at 20, that's going to be w of 20 minus w of 0. Well, w of 20, we can take that right out of the table. W of 20 is 71 degrees Fahrenheit, and then w of 0 is 55.0 degrees Fahrenheit. And if you take that difference, I think what you end up with is 16 degrees Fahrenheit. If you think about the units there, the units of w prime, we discussed this in the video for part A, units of w prime would be degrees Fahrenheit per minute. And then the units of this differential right here are the same units that t has, and the units of t would be minutes. So degrees Fahrenheit per minute times minutes gives us an answer that has just units of degrees Fahrenheit. So what does this number of degrees Fahrenheit represent? Well, really, it's just the difference between the temperature of the water at t equals 20 and the temperature of the water at t equals 0.